Hello, this is a short lecture on multivariate data analysis, and what it'll be is more or less a brief overview on some of the concepts that we have associated with multivariate data analysis. So when we think about what MV analysis is really, as the name would imply, using multiple measures as opposed to individual measures to be able to describe our subjects or our objects that are in question, whether they're consumers or competitors, maybe a product set, or maybe even elements of our own business operation, something along those lines. If you think about the research process in general, consider that there are three different major stages or types of research, and you may be familiar with these, but we think about exploratory research as research that's happening where we want to find out or uncover a series of variables that might relate to the topic that we're studying. When we focus on descriptive research, then what we're looking to do is look at maybe statistical descriptions of the variables that we have that we're interested in. So we want to use those variables to describe our subjects that we're under investigation. And then finally, though, causal research is when we want to look at different variables and their interrelatedness. And that's really where we get into multivariate analysis and the use of an application of multivariate methods are really used in causal research when we want to prove or disprove relationships between variables, especially in a cause-effect type of environment. So this requires a certain thinking, if you will, of what multivariate data methods and analysis can provide for you. And so in a sum, this is a process that relates to the interrelatedness or connectedness between sets of variables as opposed to individual variables. This has deeper meaning in that we assume, maybe either through theory or through conjecture, that variables have relationships with each other, and when you put a bunch of them together, there's a structure that tells us more than we would ever know if those variables were used separately. So how we use this then, measurements like this, the multivariate sets will capture interactions between variables. So when one causes the other, we can look at that interaction and we can see what happens. And then if we take a bunch of variables, we can look at how they not only interact with each other, but then interact with whatever the dependent variables of interest are. So we can look at those interactions. We can also use multivariate analysis and approaches to help explain and predict how we think variables will go together. And then finally, we use it in decision making. So if we have a decision to make and we want to know the likelihood of some event happening, we might be able to predict that. So maybe do some forecasting or some prediction or something along those lines. Okay, so continuing on, again, why we use a multivariate approach. We think a system of equations or a system of relationships that are all captured at once are more realistic. So realism is one of these things that we think about as we move forward. And, when we think about univariate analysis, we're thinking about one maybe dependent variable or a couple variables, maybe one variable relating to another, or we think of things happening in a singular sense. However, when we shift to multivariate analysis, we might have a series of systems happening at once, and then they relating to each other. So we would maybe have multiple dependent variables as opposed to a single dependent variable. Plus, we have the interactions between different variables, but also different systems of variables. So imagine, if you would, maybe 2 or 3 regression analyses or regression formulas all working simultaneously, maybe to explain a phenomenon or an event. And in the past, when we think about a univariate approach, we might think of just one regression and taking that by itself. But now maybe what we'll think about, when we do like simultaneous equation modeling, we think about multiple regression formulas all happening at the same time, and then also having an interaction with each other. So obviously this adds an element of complexity that doesn't exist in a univariate sense. But with that complexity comes robustness, and this idea that reality is better captured by having multiple equations as opposed to just a single equation. As just a point of reference, think about this this formula here, where we have an outcome variable of sales, and it's being predicted by loyalty, commitment, and satisfaction. So what happens here is we have an outcome, which we're very interested in, of course, and we have these other aspects of what we do in marketing, like we build customer loyalty, we measure consumer behavior, elements of commitment, and we also want to provide a lot of satisfaction or positive affect for our customers. But one of the things to think about here is that loyalty, commitment, and satisfaction, those 3 things in and of themselves are fairly difficult to measure and often require multiple measures to do so. So you could actually have a multi-item or multi-variable formula that measures loyalty, and then you could have a second multi-level or multi-variable formula that measures commitment, and then you could have a third one that measures satisfaction. And those 3 separate ideas or concepts all come together to help us predict sales. So in this case, this would be probably modeled with what we call a higher order like regression model of some type, where we have some predictor of loyalty, then commitment, and then satisfaction, and then those results would all come together to maybe indicate sales. So this is kind of touching on the elements of the sophistication of the process here, or the complexity of the process. But while it becomes more complex, it also helps us distinguish and measure reality probably a little bit better than if we had things on in a univariate type of an approach. So multivariate thinking then requires kind of a second or third level of structure to your data, is really kind of what we're thinking about. A lot of the same principles still exist, but the data applications are a little bit different. So from a practical sense, in practice, where we use multivariate analysis is all over the place. So when we're doing market segmenting, we absolutely want to split up our generic market into smaller homogeneous segments of consumers, and we use a lot of variables then to be able to determine whether a consumer is in one target market or maybe in another. We can do conjoint analysis when we want to design new products. So when we have, say we are designing a new product and the new product has 20 or 30 features, which features should we choose? Which features are most desirable by the customer? Which features go together best to create the most optimal product that would produce the most number of sales? Forecasting, of course, is a big deal in everything that we do. So forecasting sales, developing forecast models is something that we want to do. Group differences, profit maximization models, and other elements that we do in the marketing mix, including media, buying, purchasing, advertising, and things of that nature, would be practical applications. So lots of ways we can use the methods of multivariate analysis in practice, but then also in research applications too. So we certainly want to be able to make predictions. So like one example might be when we have a research situation where we want to predict an outcome based on the information that we have. So maybe we want to either predict a behavior or we want to predict a group assignment, as I mentioned before. So maybe we observe some behaviors and then we want to classify those behaviors by group. Maybe with consumers, or maybe we have a lot of, in this case, demographic information, and we want to take that demographic information based on past experience and group our consumers maybe on those measures. We could certainly do that as well. So thinking about placing consumers, being able to make certain predictions based on the variables that we have, that's kind of one of the areas that we want to do or think about from a research perspective. We also have this idea, though, that we build in a lot of structure in our data, and being able to construct a data set that has more meaning to it. And in this example here, we have a term called a latent variable. Sometimes we call these constructs, but a latent variable is something that it's a variable, or it's something that's happening but it's not directly observable. So in this example here, we have a latent variable called love, which is an emotion, and we can't really see love, but we know love exists. So what we want to do is we want to take other measurable variables, things that we could actually measure, and then use them together as a system to create a structured formula, if you will, that would represent the latent construct love. So, being able to measure things we don't see in a series of equations is something that we can do. Also, we have this idea of data reduction. And these are just a couple examples of research applications and some practical applications before. When we reduce data, think about if we have a data set and like the example before where we had product attributes or product characteristics. I'm trying to decide the best features of a product to include. Well, if I have 20 or 30 features, that's way too many. I might need to narrow that down, and so maybe through data analysis, I find 5 or 6 features are all kind of very similar to each other, and so what I do is I kind of treat them together as one feature as opposed to 5 or 6, and I've reduced my data set from that 5 or 6 variable down to one variable. So that's like a data reduction idea. And again, we're looking for structure, and we're looking for interactiveness and connectiveness between variables that would allow us, allow us to be able to make such a change. Okay, so there are a lot of things we want to do with data. Remember, though, that we want to keep this in the context of research. So, it's like multivariate analyses are like a set of toolbox. It's like a toolbox that you have that you want to be able to pull out the right tool to do the job. And so if you have a lot of tools in your toolbox, then you'll be able to solve a lot of problems, right? And be able to do some really neat research. But you want to be able to keep it in the research context. So don't forget that as we think about research, we want to think about why we're doing research and what our process will be. So even though you just have a data set, don't forget about, like, we have a purpose and we have a reason for doing the research that we're doing. We want to solve a certain problem, or we have some type of a research question that we ultimately want to answer. So we want to know why the research was being proposed that we're doing, what we want to know, We want to think about how the research has been done and will be done moving forward, what our process will be, all in the context of doing research. And again, just because you simply have a data set, don't lose sight of maybe the general purpose of why you're even analyzing the data. And again, we have a lot of different approaches that we can use, a lot of different statistical approaches and data approaches in multivariate. So think of that as your toolbox, and you want to be able to pull out the right tool for the right job. Other things we're going to want to think about as we move forward, we want to understand who we're measuring, what the units of measurement are, who our sample was. We want to think about, we're going to talk about data distributions, we're going to talk about data assumptions and what we think the data should look like and what it actually does look like. And we also want to understand, again, in the context of a research program, we want to understand about how the data was collected, and kind of where the data came from, what the data is measuring. We want to make sure, for instance, we have a list of the actual questions that were asked, that if it was a survey, we want to know exactly how and when the survey was conducted and things of that nature, because all of that talks to the data and kind of explains where the data was. It's also important because it puts it in context. So, for instance, if you think that the data is flawed or there are limitations in it, it'll help explain some of those limitations. So I like to say a good data scientist knows where and how they got their data. So make sure that you're comfortable with that process too when we go into this multivariate experience. Okay, so finally, we can think of this as happening at multi-levels or multi-steps in terms of a research process. We want to define the research problem, the objectives, and we want to think about the multivariate techniques we're going to use. Okay, so those techniques you use will depend on the type of data that you have. So the data will drive the method. So you want to collect the correct data to begin with in order to be able to use the methods that you want. We want to be able to develop and think about our analysis plan, like what steps we're going to take, how we're going to approach the analysis of doing the research. We're going to evaluate the assumptions of the data, making sure that the data is in the right shape and form so that we can do the analyses that we want to do. We want to go ahead and run our data assessment, do our statistical tests. We want to interpret the variate. So as a variate is the series of variables. So if I create, for instance, a regression formula that has 5 or 6 variables in it, that regression formula is the variate. That's what we call the variate. And then we want to measure for fit, make sure that the model and the data that we're or the results that we're gathering then, we want to make sure that they seem valid, and that it's reliable, and that the integrity of our results is sufficient for the decisions that we're going to make. Okay, so this has been just a short little overview of multivariate thinking, kind of just in general what multivariate is about. Again, this is a deeper, broader view of data, the structure of data, how variables we maybe theoretically or through experience practically we know that they go together, and so we want to be able to measure that relatedness and interrelatedness of series of variables and then in system format, and that will help us move forward. Okay, thanks.